Okay, so a slightly tricky bit here on finding minimums and maximums. Say we wanted to find the maximum or the minimum displacement a particle reaches from the origin. So how far does it get away from its starting position? To do that, we want to find the point at which the velocity is zero. The reason for that is when a particle has zero velocity, it probably means it's just about to turn round from having positive velocity to negative velocity. That means temporarily it's going to be as far away as it could be before it turns around and starts coming back towards the origin. Okay, so basically we're looking for when the velocity is zero. In the same way, if we want the maximum or the minimum velocity that a particle reaches, we want to find the time at which the acceleration is zero. Because if the acceleration is zero, it probably means it's just finished accelerating and it's about to start decelerating. So at that point, just as it finishes accelerating, it's its maximum velocity it's ever going to have. This is exactly the same as finding minimums and maximums in pure maths. When we looked at the first and second derivatives and we set the derivative to zero, it's exactly the same. When we want to find the maximum displacement, we set the velocity to zero because velocity is the derivative. It's the displacement differentiated. Okay, so it's exactly the same. It's just got a bit of context this time, which makes it a little bit more confusing. But it's the same thing for the acceleration and the velocity. If we want to find the maximum velocity, we set the derivative, which is acceleration, to zero and solve it. So we'll do a quick couple of examples here. So say the velocity is given by this. V is 7 over 2t squared minus 21t plus 6. Find the time at which the object reaches its maximum velocity. So maximum velocity means acceleration is temporarily zero. Okay? To find the maximum velocity, we're looking for when the acceleration is zero. So I need an expression for the acceleration, don't I? Remember that the acceleration is the velocity differentiated. Yeah? So to go from velocity to acceleration, we differentiate. That means I need to differentiate the expression I've been given in the question, which is 7 over 2t squared minus 21t plus 6. If I differentiate that, I get 7t minus 21. And that's my expression for the acceleration. Now, that is going to be equal to 0. We said the acceleration is equal to 0. From that, we can find a time. So if 7t minus 21 is 0, that means t is 3, yeah? If you bring your 21 to the side, divide by 7, you'll find t is 3 seconds. Okay, so that's the time at which the object has its maximum velocity. Well, what is that maximum velocity? Well, this is quite easy to do. All we do is go back to the original equation for the velocity, because we know what time the maximum velocity happens at now. So we just substitute in the time. We found it was at 3 seconds, so we'll substitute in 3. And solve that. So stick all that in the calculator. And we get an answer of minus 25.5. So actually, this is really kind of a minimum velocity, if you like, or it's a maximum velocity but heading backwards from the origin. Okay. So that is the maximum speed, if you like. It's a speed of 25.5 meters per second it reaches. And that is the fastest that particle will reach. Okay, its velocity will always be less than that, apart from at t equals 3. That's when it reaches its peak.